Hi everyone, we're Team Analog Devices and our project was the automatic temperature sensor fan. My name is Masanika Mom and my major is biomedical engineering.
Hello, my name's Jared Peters, and my major is also biomedical engineering.
Hello, my name is Natasha Parks. My major is mechanical engineering.
My name is Michaela Thomas, and my major is plastics engineering.
Hello, I'm the mentor for the ADI group. My name is Danielle Lee, and I am an electrical engineer.
During the summer, we're all traveling places and enjoying ourselves and the great weather. Sometimes we need to take quick stops to maybe grab a bite of ice cream or get some iced coffee from Dunks to cool off, so it seems impractical to have to go through the hassle of taking your napping child out of the comfort of their car seat or bringing your pet into a place where they may not allow them. But turning off your car or leaving them without any air conditioning is extremely unsafe. A car in the summertime could feel just like an oven. We all know that feeling when we first open our car door after it's been sitting in the sun all day. The heat just smacks you right in the face and all you want to do is just blast your AC and roll all the windows down. Heat exhaustion can take over the human body in 10 to 15 minutes, and it is harder to communicate in our fully adapted adult human bodies, never mind children and pets. This misfortunately results in the death of many young children under the age of 15 and pets of all kinds. As you can see, we have our statistics on the slides. We want to prevent these incidents from happening. A safe temperature for children and pets is keeping it under 85 degrees Fahrenheit, and that is based on the indoor temperature, not outdoors.
Here we have the materials for the booster pack. The booster pack integrates different solutions in order to complete an idea. There are multiple inputs and outputs available, such as a joystick, motion and sound sensor, the RGB LED, the microphone, the buzzer, and the color LCD display. We also have the Launchpad. Launchpad is a Wi-Fi system that allows connection between the internet and the board. Next up, we have the digital thermometer. This sensor is an analog temperature sensor which converts temperature into a voltage reading, which is then sensed by an analog pin, which is a microcontroller. Next, we have the temperature sensor. This sensor uses the property of diodes, which means that as a diode changes temperature, the voltage changes with it at a rate which is known. The sensor measures small changes in outputs based on the property of diodes. Lastly, we have the servo motor.
So we just wanted to explain the booster pack MK11 in depth and what mechanisms we were using. So we used the temperature sensor, which is right above the screen, and it's the black little bit. And then the LED light, which is the illuminated light. And then we have the servo motor, which we attached to the MK11 board.
Here we have the flow chart. We have the red, green, and blue RGB LED systems. For the blue is within temperature, is 0 to 80 degrees, so the servo motor does not turn on the fan. The blue light does still come on. As far as the green, from 80 to 100 degrees within the facility, the small area, compact car, the servo motor does not turn on the fan still because it's within range, but the LED still turns on. As far as the red zone, above 100 degrees, the fan does turn on, so is the LED. So the servo motor turns on the fan contraption because it's above 100 degrees, in order to turn to cool down the area of the car.
So this is an example of our energia coding. This is where we take the stuff from the process flow chart and actually turn it into commands that the board can understand. On the right here, we got an example of if the exterior temperature is over 100. So the first thing it does is it's going to send a thing to the serial monitor, which is like our first output. So you can see warm temperature green, that's the output we're getting every time it runs through and it goes to the warm temp. That's just to simulate our fan, which we're using the servo motor. And so what we're doing after that is sending our data to a system called Adafruit. So here's a little bit deeper into Adafruit. Adafruit is basically the software we're using to collect our data and to graph that data as shown on the right and left respectively. So on the right here, you can see as it goes through different times, you can see it keeps taking different measurements of the temperature. This is as one of our teammates is messing with it to try and get different temperatures. So on the left, you can see the graph. The beginning there is where nothing is happening, and then it spikes straight up to like 80 degrees, and it goes up and down as we continue to mess with it.
We're also very grateful to have collaborated with Analog Devices this summer. Though we're all from different branches of engineering, they taught us many things and gave us plenty of advice that we can take for years down the road, such as explaining the importance of self-branding. We were given the confidence to acknowledge our own great traits and learn more about one another's specialties. We were also encouraged to find balance between friendly viewpoints and constructive criticism, which allows an openness to accepting more ideas and improvement of communication skills. Most importantly, we all learned the steps we could take to be a great member individually and how to keep an open mind, which allowed us to have a better understanding of being a better team overall.
Here we have a reflections. For the RAMP program, as we learned, it encouraged communication and allowed students to learn some of the disciplines of engineering. Also, we was able to interact with the industry members, strengthen our networking and our professional development. The issues we did face was on Zoom was the difficulty of debugging. The project improvements, we need to add the data feed and color specifications to the LCD screen for the booster pack. Lastly, let the user change the rules. The changes the range for the fan motion.
So this is just a video simulating the hot temperatures that our mentor filmed.
Thank you for listening. Sorry for the long pause right there. Thank you for listening to our presentation. And also, when I mentioned that I was an electrical engineer, I meant I'm majoring in electrical engineering, so I'm not an electrical engineer yet. But thank you for listening. And huge applause for my wonderful mentees.